Hello everybody, welcome again in our lecture session, and today we are going to discuss physics form 2, and the topic to be discussed is motion in a straight line, but we will focus on position term graph together with equations of motion. By starting with the first concept to be discussed is position term graph. Within position term graph, we say that we can represent displacement, velocity, acceleration by using a graph. Means that the graph which shows the distance or displacement against time, we will call it a distance or displacement time graph. But the graph which shows the relationship between velocity, time, is what we call velocity time graph. Means velocity time graph, it shows the relationship between velocity versus time. As we can see in the first diagram, we have a displacement against the time. This is called a distance or displacement time graph. But also we have velocity time graph, whereby there is plot of velocity against the time. That is the representation of velocity time graph. Now let's consider another graph. Let's consider another graph. Consider a body starting at rest. A body starting at rest. At rest means there is 0 meter per second, which is initial velocity. Means in this there is velocity in meter per second, but in horizontal or in x-axis there is time in second. Now consider the body starting to move at rest and then accelerate up to some point where it have a velocity v. Then after having the velocity v, it also travel with a uniform acceleration or a uniform velocity. But here we will have a time, let's call t1, and after accelerating it will have a time t2. But after reaching a certain time t2, the body returns to the horizontal position. Means the body or the object accelerate or decelerate to a certain distance. Means here we have t3. That is an object. So here we say there is acceleration. But here where the velocity of the body does not change, but the time is still changing, is what we call uniform velocity. And the point where the body return to its ground state, or the body return to the original position, we call it a retardation. So here is retardation. So that is how you can represent the velocity time graph of any object or car which is in motion. So now Let's look some of examples which can be explained by using velocity time graph. So in this graph you can be asked to calculate the total distance which is being moved. So to calculate the total distance travel is just to calculate the distance from this point up to this point. The point where the body starts to move up to the point where the body returns to the ground. Means that total distance will be equal to S This will be the total distance. But in order to calculate total area, now let's look some examples. Example 1, a car travel with uniform velocity which is 30 meters per second for 5 seconds, and then comes to rest katika 10 seconds with uniform acceleration. Then the first question, you are required to draw a velocity time graph of the motion. Kipengele cha pili, utafute find the total distance travel. Find the total distance traveled. But the final question is to find average acceleration. Let's say average velocity. So you are being given a body which is just traveling with a uniform acceleration, which was with a uniform velocity which was 30 meters per second for 5 seconds, and then the body come to rest after 10 seconds. So the first step is to draw the velocity time graph. Let's say we are just drawing our velocity time graph representing our problem. So first is to draw velocity time graph. Means at the vertical there will be velocity in meter per second, but in horizontal there will be time. into second. That is step number 1. But step number 2, you are being given a car which is in a uniform velocity. Means it does not start at the rest, but it have some velocities which is uniform, and it was 30 meter per second. The car just traveling up to time which was 5 seconds. After that, the car starting to decelerate or starting to come into rest. Means after coming to rest in 10 minutes, means 5 plus 10, we got the time is equal to 15 seconds. So that is how you can represent the problem which you are being given by using velocity time graph. Now let's find the total distance. To find the total distance is equal to the area which is being covered by the graph. So if we find the area of this figure, we will already find the total distance traveled by the car. Kwa hiyo ili upate urefu ambao ili gari itakuwa limesafiri, utatafuta eneo la hilo umbo linaloonekana hapo. Kwa let's find the area. Kipengele cha pili, total distance. Tunakumbuka kwamba total distance ambao ni S, kwamba S sawa na total area covered. Na total area tutapataje? Ukiangalia umbo letu ni trapezium. So tutatumia kanuni ya trapezium kutafuta area ya hilo umbo hapo. Kwa hiyo itakuwa sawasawa kwamba S will be equal to half A plus B. So ukitafuta hii pembe tatu ya kwanza, lakini pia tuna umbo ambalo ni mstatili. Kwa hiyo kuna maumbo mawili. Umbo la kwanza ni la pembe tatu, umbo la pili ni la mstatili. Kwa hiyo ukitafuta eneo la umbo zima utapata ni sawasawa na area ambao tutakuwa tumeulizwa, au utakuwa ni sawasawa na distance which is being traveled by the car. So tutafanyaje? Ili tupate distance itakuwa ni sawasawa kuchukua S is equal to, hii ni eneo la hii pembe tatu, A plus B. So it will become, or you can use the formula kwamba utachukua urefu utazidisha na time mpaka hapa, then utajumlisha na hichi cha huku, utakuwa umeshapata area ulioulizwa. Okay, let's find. So it will become 30 multiplied by 5. This is the first area to find. Then after that you will plus with another 30 times 10, but you will divide by 2. So you will get 150 plus 150. So the distance will be equal to meter. So you will say distance traveled is 300 meter. Kwa hivyo ndivyo utakavyokuwa umeweza kutafuta the distance which is being traveled by the car. So let's finish in third part, which we are required to find the average velocity. Average velocity. How we can find the average velocity which we are being required to find? We know that we already calculate the distance. We already have the distance traveled ambayo ilikuwa ni 300 meter, lakini we have a total time kwamba time taken for the boat ilikuwa ni 15 second. So kumpata average velocity ni sawasawa, say tuashumu ni v sawasawa na s over t, ambayo itakuwa sawasawa, s yetu ni 300 mita, tutagawanya kwa t yetu ambayo ni 15 second. Kwa v sawasawa na ngapi? Tutapata ni, ngoja tugawanye tuone itakuja ni ngapi. Ila ukigawanya kwa 15 hapa ni 1, kwa 15 2, kwa utapata ni 20 meter per second. So utasema average velocity is 20 meter per second. Hivyo ndivyo unavyoweza kutafuta average velocity ukiwa umeulizwa. Kwa kusema hivyo, tuingie katika part 2 of our today lesson, which is equations of motion. So within equations of motion, tuna equation 3 za motion in a straight line. Equation ya kwanza tunasema kwamba ukiwa umepewa is equal to u plus, we have v is equal to u plus at. This is the first equation of motion in a straight line. But also the second equation is relating the s, which is equal to u t plus half a t square. This is the second equation, and the last equation of the motion is what we let v square is equal to u square plus 2as. Those are the three equations of motion which represent the motion in a straight line. So now let's look some examples on how we can use those equations to find some parameters.